Good morning. I'm meteorologist Ted Keller. I wanted to bring you an update today on the severe weather hazard in the Ohio River Valley, more particularly in southern Illinois and Indiana. Let's start out this morning with the visible satellite loop, and we're seeing a lot of activity here, especially right here in Kansas, Missouri, Arkansas. You see this arc. There's a dry slot of air pushing in, surging into the area in question, which is basically over here. I'll show you some more detail on that in a minute. We have one low circulating up here in the upper atmosphere over Lake Superior, and another shortwave trough right here. And that's what's driving this entire process to create the severe weather possibilities out in this area. Let's take a look at the details. So they did up the percentage on this. So yesterday, this slight risk area, number 2 out of 5, covered about the same ground, but they've now added an enhanced area, which is the orange color, level 3 out of 5. And primarily, this is because of a couple of supercells that are forecast to develop here by most of the models. And could they be tornadic? Yes, actually, they have the tornado percentage pretty high. It's at 10%. That was the opening graphic I showed you. And that barely gets like Terre Haute, Indiana, but southern Indiana, just north of the river. But, Evansville is still in the 5% risk. So this is, when we take a look at where models produce actual thunderstorms, there's some variance here. So obviously, that's why we have a tapered scale. But 5% is 5% chance. That's Brown of a tornado within a 25-mile radius. And of course, 10%, same rule, only a slightly better chance. There is also, and this is somewhat interesting, is that there is a significant tornado probability being put out by the Storm Prediction Center. So this is a hatched area here, which coincides with the enhanced area exactly. And it's a 10% chance or greater probability of a stronger tornado. So on the upper end of the scale, so you have EF2 through EF5, so 2, 3, 4, and 5 within 25 miles of a point. So that's rather significant. Other things bolster this. We have this CSU Machine-Learning has a 5% tornado risk. That does extend that a little bit more into parts of Kentucky than the official forecast. And there's some hail and high wind threats with this too. And if we finally take a look at Nadocast, it has that 5% area just about in the same area, maybe a little more to the north than the SPC has drawn it, but not by a whole significant amount. Again, this is something where if you're living in those areas, you just need to start monitoring more closely your local weather and see exactly where these storms set up. At the 500 millibar flow, like I said, there's one low up here over Lake Superior. There's another short wave right here. The upper level winds are very strong. And in particular, in this zone right here, we tend to get a lot of uplift. So if you have a strong jet max like this area to the left and toward the front of the jet max is an area of uplift and increasing instability. It's favorable for severe weather. So if we take a look, this is all the HRRR model. Here's the HRRR model, and that again was for noon. The last map, same one here. We have a low pressure area developing over Kansas. And this deepening of the low is also significant for the tornado possibilities because a lot of times the missing ingredient for severe weather with regard to tornadoes is we don't have that low level turning of the wind backing really to the southeast to get the lower part of the thunderstorm favorable for tornado development. You can get rotating storms like supercells, but the final connection is made a very, very shallow layer near the surface. If we take a look at the dew points, we're going to change perspectives here. So here's Missouri, here's Illinois, here's Indiana. There's been a healthy return flow. So we look at the scale here. The blues are 60-degree dew points. These are all 50-degree dew points here. This is at 8 a.m. Central Standard Time. So remember that low developing right there. So as that tracks this way, we'll show you that in a minute. It's going to help draw out some of that more unstable air at the surface. Here is the loop of what's going to happen, surface low, simulated radar. Here's the first look at some of these supercells that are forecast to develop in this area here as the low tracks from eastern Kansas up into western Illinois, and that's through 9 p.m. tonight. So this could go on here toward the end of the loop. We still have other thunderstorms that develop in parts of Kentucky. Now, the instability may be a little bit lacking or not. I mean, we're going to have to watch that into the evening, I think, very, very closely. So here are some still shots at 11 a.m. This is simulated radar, and also I've included updraft helicity. That's really basically supercell strength. So where is the supercell? Is the thunderstorm actually rotating? And it'll show a mark on here. So when these storms first develop east of St. Louis at 11 a.m., There isn't any sign of that yet. But if we go 2 more hours later to 1 p.m., we see the little track right there, the little black line that indicates that cell that right there has developed rotation. I think maybe this one too, right along the Ohio River. And if we move ahead to 3, again, you can kind of see a snail trail of that helicity right there, right there. Maybe another candidate in there somewhere. Hard to tell. Again, if I look at this model data an hour later, it could change the position of these a little bit. But focusing on 3 p.m. seems to be when the maximum heating will occur, instability. Now, this time of year, this is Cape. We use this a lot. There's nothing on here that exceeds 1,000. It gets close, though, 800, 900. And that's actually this time of year pretty good. One indicator, though, is we have strong low-level CAPE, especially in this area here. And low-level CAPE is basically if the sun can come out and really heat the ground, and we get very steep lapse rates, this low-level CAPE can be very important. So again, if you're looking for tornado development, if your instability is bottom-loaded like that and you have proper shear profiles, in other words, that wind is spinning like I indicated, you can do it this time of year. You don't have to have crazy instability. And this is the tendency of the rotation of the atmosphere in the lower kilometer of the atmosphere, very, very low down. And this is again at 3 p.m. Final map I'll show you, and it's starting to push some pretty high helicity, storm relative helicity values. This is just, again, the tendency for the lowest part of the storm to have significant rotation. So anything in the blue would be okay. Yellow is actually pretty significant, and often this is storm-based. So in other words, the environment that created the storm helps to induce a couple of counties' large area of enhanced, well, whatever we're looking at in this case is helicity. So again, something to monitor. I'll keep an eye on it today. Again, southern Illinois, southern Indiana, and maybe we'll go ahead and put northwest Kentucky, northern Kentucky into that as well.